So we're now on to chapter 7. So first off, inverse trig functions. So y equals the inverse sine of x, given that x is equal to sine y. Right? And so here the values are going to be from -1 to +1, and my angle is from -π/2 to π/2. So that is my sine function. We can also do the same thing with our cosine function, inverse cosine of x. Again, given that x is equal to cosine y. And again, cosine only goes between -1 and +1. And the interval here is between 0 and pi. And then the next one is going to be our tangent function, inverse tangent. And so x equals tan y. And so here we're now from -infinity to infinity. And my angle is between -π/2 and π/2. So then a few other things here in regards to this. So first off, if we do the sine inverse of sine x, you just get x. And if I did the sine of the inverse sine, we also get x. So let's say here I want to solve for x. And so we have 3 inverse sine x equals pi. So if I want to solve for x, first I'm going to do is divide by 3. So inverse sine of x equals pi/3. And so this then means that x is going to equal the sine of pi/3. And so here you have to remember in terms of those exact values. So again, there are those charts in the book for 30 degrees, 45 degrees, 60 degrees. So those things. So pi/3, pi/4, pi/6. Okay? So exact values. Right. So that's my sine, cosine, and tangent functions. So now we can talk about the other three. And so y equals inverse secant of x. And so x is going to equal secant y. Right. And so the absolute value of x is now going to be greater than or equal to 1. And my y value is in between 0 and pi. And y cannot be pi/2. Next one is cosecant. So inverse cosecant x. So x equals cosecant y. And again, my values here are going to be absolute value greater than or equal to 1. And we're now on the interval from -π/2 to pi/2. And now this time, y cannot equal 0. And then lastly, cotangent. inverse cotangent x, or x equals cotangent y. And so again, here we're from negative infinity. Not the comma. Right? So negative infinity and to infinity. Right? Should be x. Should be my x. Right? Make that an x. Okay. Try this again. X and infinity. And here, and the y value is between 0 and pi. Right. So we have the inverses of all our trig functions. Right. So let's say we had a question like this. Find the exact value, the sine of the inverse tangent of 1/2. Right? All right. So if that's true, then that would mean that theta is going to be the inverse tangent of 1/2. And so tan theta is equal to 1/2. Right? So if I were to draw that out, that would mean we'd have to be in the first quadrant. So here's my point. And so this is going to be the point 2, 1. Right? And if I make my triangle, so drop this straight down, we know this is 2. We know this is 1. So we can find the hypotenuse of that triangle, because after all, that's going to be 1 squared plus 2 squared equals c squared. So 5 equals c squared. So c is going to be the square root of 5. Right? So this is going to be the square root of 5. And here's my angle theta in here. So we can now say, okay, so sine of theta is going to be 1/, the square root of 5. But then we have to rationalize our denominator. So we multiply the top and bottom by the square root of 5 over the square root of 5. And so we end up with a final answer of the square root of 5 over 5. So we're done. Okay. Let's see. So let's say we now want to solve this trig equation. So solve and so now we got, and we want to solve this over the interval from 0 to 2 pi. And so now I got 2 sine theta plus 1 equals 0. So we want to get theta. So what we're going to do is subtract 1. Right? So 2 sine theta equals minus 1. And then we're going to divide by 2. So sine theta equals negative 1/2. And so then theta is going to be the inverse sine of negative 1/2. And we're doing this in radians, all right? And so in radians, this number is going to come out to be negative pi over 6. Okay. So let's look at what that would mean in terms of my angle. So negative pi over 6, that puts me down here. Right? And so let's say, well, I want to know what that angle is. Again, we said we wanted it between 0 and 2 pi, which means we want to know what is this angle here going to be. So that angle, so negative pi over 6 is going to be the same thing as 11 pi over 6, right? But sine is negative in both the third and the fourth quadrant, and so their other angle is actually going to be over here. And so my other angle is going to be 7 pi over 6. So I get two answers, 11 pi over 6 and 7 pi over 6. Right? Let's see, another example. Let's say I have this one. Sine squared theta equals 2 cosine theta plus 2. Well, for this one, we're going to make use of the Pythagorean identity. So sine squared plus cosine squared equals 1. And so sine squared is going to be 1 minus cosine squared. So I can substitute that in. So I get 1 minus cosine squared theta equals 2 cosine theta plus 2. And we now want to make that equal to 0. So I'm going to subtract the 1, add cosine squared. And subtract the 1 and add cosine squared. So I get 0 is going to equal cosine squared theta plus 2 cosine theta plus 1. And this is now a quadratic, and it is factorable. And so this is going to be cosine theta plus 1 times cosine theta plus 1. So that would mean that cosine theta plus 1 would have to equal 0. And then if I subtract 1, so cosine theta equals negative 1, which means then the theta is going to be the inverse cosine of negative 1. And this is just going to be pi. All right. Well, then the chapter gives you a whole bunch of identities and stuff. And so let's list some of those. All right. And so first off, we have in terms of some of the identities. So trig identities. So tan theta is equal to sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. We then also have the reciprocal ones. So cosecant is 1 over sine. Secant is 1 over cosine. And then cotangent is 1 over tangent. And then we get to the Pythagorean, and I already put one up earlier, and that was sine squared plus cosine squared equals 1. And then there's tan squared theta plus 1 equals secant squared. And then the last one is cotangent squared plus 1 equals cosecant squared. So there's those. Okay. So then we get a question that looks something like this and says, prove the identity. So sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta equals 2 cosecant theta. So basically you want to prove that the left side is equal to what we have on the right side. Well, we have fractions on the left, and so in order to add fractions, we need to have a common denominator. So that would mean this one, I'm going to multiply this by sine theta over sine theta. And then the other one, I'm going to multiply top and bottom by 1 plus cosine theta over 1 plus cosine theta. So if I do that, what do I get? So this is going to be sine squared theta over 1 plus cosine theta times sine theta plus 1 plus cosine theta squared over 1 plus cosine theta sine theta. Okay. All right. And so now what do we have? So we look at this and we say, okay, well, this is going to be a sine squared theta. And if I look at 1 plus cosine theta squared, well, this is going to give me 1 plus 2 cosine theta plus a cosine squared theta over 1 plus cosine theta sine theta. Right? Right? So we multiply that out. Right? Well, now we can make use of one of those Pythagorean identities, because now I have that. I do have, so sine squared plus cosine squared is equal to 1. Right? And so I can make that substitution. And so we get 1 plus 2 cosine theta over 1 plus cosine theta sine theta. Continuing with the top, this is going to give me 2 plus 2 cosine theta over 1 plus cosine theta sine theta. And then I can factor a 2 out of the top, so this will be 2, 1 plus cosine theta over 1 plus cosine theta sine theta. Okay. And then now the 1 plus cosines cancel out. And so we have 2 over sine theta. And then, of course, this would be the same thing as 2 times 1 over sine theta. And 1 over sine, we said, was cosecant. And so this is going to be 2 cosecant theta. And it does indeed equal to cosecant theta. Right? So we proved that it worked. Right? Let's see, other formulas you're going to see in this chapter. So we got, first off, in terms of these ones, sum and difference formulas. So we have cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. And then we have cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And we also have, in terms of for our sine function, so we have sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And then we can have sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine of beta. So we have sine functions, we have one for cosine, and then we also have a set for tangent. And so we can have tan alpha plus beta equals tan alpha plus tan beta over 1 minus tan alpha tan beta. And then we also have tan alpha minus beta equals tan alpha minus tan beta over 1 plus tan alpha tan beta. All right. So let's look at an example of a problem dealing with this. And so let's do this one. We want to evaluate the sine of alpha plus beta. Right? And so here they give you a couple of circles here. Very good circle. That's right. So here's my point here. Coordinates of this point is given by x comma 1. And this is alpha. And this circle is x squared plus y squared is equal to 4. Right? So that would mean if I look at the triangle that's being generated here, we'd have my triangle is here. So we know this is 1, right? And so we have x squared plus y squared equals 4, right? And so that would mean that, so if c squared equals 4, that would mean c has to equal 2. So this is going to be 2, which means this side is going to be the square root of 3. Right? So we need to know the sine and cosine of this. And so we know that the sine of alpha is going to be 1/2. And then the cosine of alpha is going to be the square root of 3 over 2. Right? Now then they also give you this other figure. And so now we have my other circle. And my triangle is now down here. And the coordinates here are 1/3 y. And here is now my beta angle. Okay. And so let's look at this triangle. And this one, the circle is given by x squared plus y squared equals 1. So that would mean my triangle here. Right? So here's my triangle. And so this is 1/3. This is going to be 1. And this is going to be the square root of 8 over 3. Right? And so again, we can look in terms of my sine and cosine. So sine is going to be the square root of 8 over 3. And then my cosine is going to be 1/3. Okay. So now that we know what everything is, let's see if we can do this. So this is going to be sine alpha, cosine beta, plus cosine alpha, sine of beta. So now it's a matter of taking all our numbers and plugging in. Sine of alpha is 1/2. Cosine beta is 1/3. Cosine alpha, square root of 3 over 2. Sine beta, square root of 8. Oh, square root of 8. Let's make an 8. Square root of 8 over 3. Now we got the numbers. We can do our math. And so 1/2 times 1/3, this is going to give me 1 over 6. Plus, this is going to be the square root of 24 over 6. But square root of 24, remember in terms of simplifying radicals, so let's do this over here. This is going to be the square root of 4 times the square root of 6, so 2 square root 6. So this is going to be 1 over 6 plus 2 square root of 6 over 6. But then, of course, that could be reduced. And so we get the square root of 6, all right, over 3. Right? Right? And actually, sorry, that should be a negative. That should be negative, sorry. So yeah, this should be a negative because after all, it is down, right? So this is going to be a negative. And so let me correct that. And so this is going to become, and so this will be 1 minus that. Right? And let's leave it all in 6, so it makes it easier to deal with. Right? And so with that, we are done. Right? So you do got to make sure where your triangle is, whether the signs are going to be positive or negative. Right? All right. All right, still got a few more of the formulas which you're going to see in this chapter. And so we still have the next set, which are called double angle formulas. And so sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta is equal to cosine squared minus sine squared. Now it ends up for cosine 2 theta, there are several variations. It's also equal to 1 minus 2 sine squared theta. And it's also equal to 2 cosine squared minus 1. Right? And then tangent 2 theta is equal to 2 tan theta over 1 minus tangent squared. So those are my double angles. And then the last set that they give you are the half angle formulas. So now we get sine squared of alpha over 2 equals 1 minus cosine alpha over 2. Cosine squared alpha over 2 equals 1 plus cosine alpha over 2. And tangent squared alpha over 2 equals 1 minus cosine alpha, alpha, change that, back to alpha, cosine alpha over 1 plus cosine alpha. Right? Now you notice all these are sine squared, cosine squared, tangent squared, which means, of course, if I want to do it just in terms of sine, cosine, and tangent, I just take the square root of the other side. Right? And so you'll see that in the next set here, and that the sine of alpha over 2 is going to be plus or minus the square root of 1 minus cosine alpha over 2, and then the cosine of alpha over 2 is going to be plus or minus 1 plus cosine alpha over 2, and then the tangent of alpha over 2 is going to equal plus or minus, and this will be 1 minus cosine alpha over 1 plus cosine alpha. So let's do one last example of a question. And so we want to solve on the interval (0 to 2 pi). And so we have 2 sine theta. Actually, sorry, let me start at the beginning here. We have sine of 2 theta equals cosine theta. Right? Right. Well, we got double angles, so we got sine of 2 theta. Right? And so from our formulas, this will become 2 sine theta cosine theta is equal to cosine theta. Right? So now I'm going to take the cosine theta to the other side and set this equal to 0. Right? And so we have 2 sine theta cosine theta minus cosine theta equals 0. And then, of course, now I can factor out a cosine theta. So cosine theta, and this will be 2 sine theta minus 1 equals 0. Okay. And so that would mean either cosine theta equals 0 or 2 sine theta minus 1 equals 0. And so here for this one, that would mean theta is going to be the inverse cosine of 0. And so this is going to be pi over 2. And it would also be 3 pi over 2. See, we're doing the interval 0 to 2 pi. And then over here, we take this one and solve. So here I'm going to add 1 and add 1. So 2 sine theta is equal to 1. And then we're going to divide by 2. So sine theta is going to be 1/2, which means then that theta is going to be inverse sine of 1/2. And so this is going to give us pi over 6. And then also the other one would be 5 pi over 6. And so we have all the answers in that interval from 0 to 2 pi for that question. And that will conclude this video.